Hello, I'm Craig Lund. Today I'm going to show you the first public demonstration of a BY8 Gen 3 PCI Express hard IP block running on a Virtex-7 X690T FPGA. Here you see the Virtex-7 devices that are BY8 Gen 3 capable and have the hard IP block. For those devices that only have Gen 2 hard IP blocks, soft IP solutions for Gen 3 are available from our third-party alliance partners Northwest Logic and PLDA. Virtex-7 XT and HT FPGAs are the first generation of FPGAs that contain a PCI Express Gen 3 hard IP block. With every new generation of devices, the PCIe hard IP block from Xilinx evolves and integrates more advanced features. These features include support for advanced error reporting, multiple functions, single root I/O virtualization or SRIOV, and atomic operations, just to name a few. To enable an improved customer experience, several ease-of-use features have been added. These include separate completer and requester interfaces, data alignment options, and tag management. Please see the PCI Express Gen 3 user guide for a full list of features and a description of this Gen 3 hard IP block. Here I have a Virtex-7 X690T FPGA on a Xilinx development board that is designed to the PCI Express form factor. Many of the Xilinx boards and all of the Xilinx connectivity kits are designed in PCI Express form factor to enable customer IP and software development. Let's take a look at the Virtex-7 X690T in a real PCI Express Gen 3 system, verify the card is recognized in the system and has also link trained to BY8 Gen 3 lane width and speeds. On this Intel Sandy Bridge E desktop system, I have the board plugged into one of the PCI Express Gen 3 slots. I've pre-downloaded a bitstream with our PCI Express Gen 3 hard IP block and a throughput test application. So I've already started the computer, so now let's verify that the device is link trained to Gen 3 line rate and run the throughput test application. In this particular example, I'm running a demonstration using Linux. The server is booted up, and now we're going to run a program called LSPCI, which will scan all of the devices on the PCI bus in the system. To see just the Xilinx device, I'm going to search for 10EE, which is the Xilinx PCI Express vendor ID. As I've highlighted, the Xilinx device was found and the card has advertised the link capability of BY8 Gen 3 and is also link trained to PCI Express BY8 Gen 3. So now let's run the XBMD throughput application and see what sort of bandwidth the PCI Express Gen 3 hard IP block is capable on this desktop system. Here you can see that I can define the size of the transaction layer packets, or TLPs, and how many of these TLPs I'd like to send. I can set these parameters for both the read and the write directions. In this case, I'll be writing 64 D words, or 256 byte packets to the desktop memory. And I'll be sending over 16,000 of these TLPs. This means I'll be sending over 4 megabytes of data when I hit the start button. Here you can see that the throughput on the write path. It's nearly 6.35 gigabytes per second. Now let's do the same exercise on the read path. In this case, I'll set a read request size to 128 D words, or 512 byte packets. And I'll set the number of TLPs to 8,000. This means that, again, I'll be requesting over 4 megabytes of data from the host. And here we can see that the throughput on the read path is almost 6.9 gigabytes per second. Now that's moving a lot of data in a short period of time. So that concludes our demo. Today we demonstrated the first PCI Express Gen 3 hard IP block using the Xilinx Virtex-7 X690T FPGA and showed fantastic performance well over 6 gigabytes per second in both the read and the write directions. To learn more about Xilinx solutions for PCI Express on Xilinx 7 series FPGAs, visit xilinx.com/PCIe. Thank you for watching.